Physics Project Ping Pong Ball Catapult by Aaron Kaplan, Zach Jenkins, and Hunter Williams. History of the Catapult. Catapults have been integral to siege warfare since antiquity. Though ancient catapults were one of the most effective weapons in siege warfare, various types of catapults have been used by the Greeks, Romans, and Chinese. The first catapults were early attempts to increase the range and power of a crossbow. Diodorus Siculus, a Greek historian, was the first to document the use of a mechanical arrow-firing catapult, early ballista, in 399 BC. Catapults, as we think of them, were introduced to Europe during the Middle Ages. Catapults made their exhibition in England in 1216 during the Siege of Dover. The French crossed the Channel and were the first to use catapults on English soil. With war prevalent throughout Europe during the Middle Ages, the popularity of fortified castle and city walls rose significantly. This made catapults an essential. Catapults were used to launch missiles. Many different objects were utilized. These missiles were either launched directly at the wall to cause maximum damage to the fortifications, or were launched over the wall to lay siege on the population within the protective walls. Catapults were also used to throw missiles at soldiers. The first accounted acts of biological warfare involved catapults. Bodies of the diseased were hurled over the city walls to infect the residing citizens. Catapults were used extensively throughout Europe, predominantly by the French, until 885 to 886 AD, when new defense systems rendered catapults ineffective. Types of catapults in ancient Europe. The three most common models of a catapult that were built are known as the ballista, the trebuchet, and the mangonel. Physical content of the catapult. The catapult uses a system in which a ball is placed in a carriage at the end of a rod. This rod is then put under a certain amount of tension as it is wound back. When the tension of the arm is released, the arm is swung in the forwards direction until it reaches its stopping point where the ball is released. Depending on the mass of the ball, which in our case is very minimal, as well as the acceleration/velocity of the ball, are what is used to determine the speed of the ball. Along with these calculations, a key aspect of the catapult that is often overlooked is the angle in which the ball is released from. Most often, the optimum angle of release is about 45 degrees, due to the arc of the object that is produced. It allows for an even semicircle and is easier to aim. The larger the angle of release, the straighter on the horizontal axis the ball will travel. At a 90-degree angle, the ball will be on an even plane of release and will only accelerate down on the vertical axis. And so the opposite will happen the smaller the angle of release. The smaller the angle, the greater the vertical acceleration and the higher the ball travels, but as for its distance on the horizontal axis, it does not move very far. Here one will find the calculations to the velocity, time, height, and distance of each setting in the four most powerful settings of our catapult had to offer. These are the graphs and visual displays of the data. That's the end of the presentation.